All right, here we go. It says write an inequality or compound inequality to represent each of the following. And then define your variables. So all real numbers between -5 and 4. And I'm going to take this between to mean that it includes it. So -5, 4. I'm going to put R as the real numbers. Okay, and so that means the number has to be greater than or equal to -5 and less than or equal to 4. Number 20, the temperature outside was less than 45 degrees. I'm going to use T for temperature. So the temperature was less than 45 degrees. Not or equal to, because it doesn't say it was 45 degrees or under. And then 21 says at least 600 people attended the play. I'm going to use for P for the people who attended. So P, at least 600 people. So if I have 600 as my limit, I'm saying that this number has to be greater than or equal to 600. All right, 22 through 25, looking at some inequalities here. Writing the inequality and solving it. It says it costs $80 to rent a jet ski. There's an additional $21 charge per hour. If Betsy wants to spend no more than $200 on a day of jet skiing, what are the possible numbers of full hours she can rent the jet ski? So here we go, full hours. Again, remember, you're not going to be able to pay for half an hour, 15 minutes. That typically is charged as the next full hours. So it costs her $80 a day and $21 per hour. H for hours. She wants to spend no more than 200. So we want 200 to be greater than or equal to our cost. Okay, so here's our inequality. We will solve this, subtract 80 from both sides. We get 21H is less than or equal to 120. And then 21 divided by, 120 divided by 21 gives us 5.7. So we find H to be less than or equal to 5.7. Now with that said, we can't rent the boat for 5.7 hours. And so, or the jet ski for 5.7 hours. So we say less than or equal to 5. Okay, 6 would be too much. For lunch, Amelia wants to eat at least 870 calories. The nutrition facts say that each slice of pizza has 165 calories, and a bag of chips has 220 calories, and a soda has 105 calories. How many pieces could she eat and reach her goal? So we're talking about pieces of pizza, okay, because she's going to have a bag of chips and a soda. Okay, so in her lunch, she has a bag of chips, 220, a soda, 105. And then pizza, we don't know how many pieces she's going to eat, but we know that it's 165 calories per slice. I'm going to just use S. Actually, this S here looks bad, so I'm going to say P. All right, so 105 plus 220, that gives us 325. So soda and chips is going to be 325 calories, plus 165 per piece of pizza, and we want it to be at least 870. So we're going to say greater than or equal to 870. Here's our inequality. So now we solve this. 870 minus 325 gives us 545. And so we're left with 165p is greater than or equal to 545. So in order to get how many pieces of pizza, we'll do 545 divided by 165. We find that P is greater than or equal to 3.3 pieces of pizza. Okay, so now if she wants to get at least 870 calories, I want to say that she's not going to eat 3.3 pieces of pizza because, like, what is that? Is that the crust? Is that included? To be safe, I would say she needs to eat 4 pieces of pizza, at least 4 pieces of pizza to get that calorie count. Okay. Number 24 says regulation size football must have between 12.5 and 13.5 pounds of pressure to be considered legal. Each each pump of pressure inserts 0.2 pounds of pressure. If a certain football is found to have 11.1 pounds of pressure, what are the possible amounts of pumps that can be done so the football can be considered legal? So here we go. We need to set up our boundaries. Between legal is 12.5 and 13.5. This is how our ball is legal. Okay, so our ball needs to either be greater than or equal to 12.5 or less than or equal to 13.5. Now they tell us that the ball that we have is 11.1 right now, and that each pump from the compressor gives us 0.2. Let's say P. Okay, and so what possible number of pumps? So P stands for the number of pumps. So let's solve this. And it's a compound inequality. We'll focus on getting the middle solved, and the rest will follow. So I get 1.4 here, and that gives me 0.2p. And here I'll get 2.4. Okay, and now I'll divide both of these by 0.2. So 0.2, not a negative 2. So that'll give me 7. P, and that will give me 12. So what are the possible number of pumps? Anything between 7 and 12. I can write that as a compound inequality just right away because their whole numbers make sense. Anywhere between 7 and 12 pumps gets us a legal ball. 25, my wife wants to start a small business designing decorative burlap wreaths. To start her Etsy account, the online store she would use to market her wreath and get the equipment needed to make the wreath, she has an upfront cost of $219. She figures that each wreath will cost her around $23 to make. She would sell each wreath for $49.99. Okay. Find all the possible number of wreaths sold that would allow her to make a profit. So remember, when we're talking about profit, we want the money that we make, just $49.99 per wreath, to be greater than the money that we spend, which is $219 for the startup cost and $23 per wreath. Okay, and so now we have an inequality to solve. Subtract 23 from both sides. I get 26.99. W is greater than 219. Okay, and so we can find that 219 divided by 26.99, and that gives us 8.1. Okay, and so how many wreaths must she sell? Well, we can write this two different ways. We could say, well, she could sell greater than 8 wreaths, which would mean 9, or she could sell greater or equal to 9. I'd probably prefer this answer because it stays consistent with our inequality sign, but either of these answers work out. Okay. All right, that is your study guide. See ya.